We're going to look at the question 1b from the 2018 midterm. Okay, now in this question we are to find the power in the 3 amp source, and in order to do that we need to find the current through the component and the voltage across it so that we could calculate the power. We need to do this for any source that we are trying to solve the power for. So we know the current and we need to find out the voltage across the source, and then we can compute the power. Okay, so now how do we go about doing it? So when we examine the circuit, we notice that it is seems like nodal analysis might be a good way to solve for the voltage across it. All of the components are in parallel, and so if we use the node voltage analysis, the first thing that we do is select a reference node. So we'll just select it down here, and so this will be our 0-volt reference, and then we have to label all of the other nodes, and in this case it's just one other node, and we'll just call this node A, and then the voltage there will be VA. Now when we label it like so, it means that we are specifying a voltage of VA across the components like this. So we have a VA across the 10 ohm resistor, we have a VA across the 2 amp source, the 5 ohm, the 3 amps, and the 2IX dependent source, and that's because those components are all in parallel. So now to write the equation, we assume that the node that we're operating on has the highest voltage and that all the currents flow out from it. So that node is actually all of this, okay, all of these branches, all of these conductors, and we're going to specify the node voltage equation in terms of the currents that are flowing in each of those branches. So each of those branches is going to have its own term. Okay. So now let's write the node voltage equation. So we'll do nodal at node A. Okay, so then starting with the leftmost component, the 2IX dependent source, the current for it is going to be minus 2IX because it's opposing our assumption that all of the currents flow out from VA. Next we have minus 3 amps because that's also flowing into the node against our assumption. Then we have the current flowing through the 5 ohm resistor, and the expression for that is VA over 5 ohms. Then we have another current source going into the node, minus 2A, and then we have the current through the last resistor, the 10 ohms, and that current is going to be expressed as VA over 10 ohms. And all of that is going to be equal to 0 because of KCL. So now, one thing that we can notice is that this term here represents the current through the 10 ohm resistor, and we have a definition for that current as IX, and that is the controlling current for the dependent current source. So we could use that information later. So now let's simplify our expression and sub in for IX. And we know that that's equal to VA over 10. Okay, so then when we sub in, we have minus 2 times VA over 10 minus 3 plus VA over 5. I'm just simplifying by getting rid of the units. We have minus 2 and then plus VA over 10 is equal to 0. And then if I go times 10 to that expression, we have minus 2 VA minus 30 plus 2 VA minus 20 plus VA is equal to 0. And then we can say VA is equal to 50 volts. Okay, so that is an intermediate result. So now let us go to the next page to complete it. So now what do we know? We want to find the power in the 3 amp source. So what do we know? We know that there's 3 amps flowing, okay? And then what we've done is we've solved for the voltage across all of the parallel components, so we found that was 50 volts, okay? And so now we need to write the expression. So we see the 3 amps is going to be flowing this way, just by definition. So then we can write power of the 3 amp source is equal to minus VI, okay? And when we plug in our numbers, it's going to be minus 50 volts times 3 amps, and that works out to minus 150 watts. So then, when we take the absolute value as the question requests, we get 150 watts, and since the sign was negative, it's delivering, okay? And that is the solution to question 1b. Okay, so that is the answer.